So we talked about the fact that that moving electrical charges create magnetic fields. Now we want to talk about the opposite effect, which is that changing magnetic fields can cause electrical charge to move, can cause electrical currents, a phenomenon called magnetic induction. Here I've got a really simple experimental setup. This is just an ammeter. It measures electrical current. This is a bunch of coils of wire wrapped around a plastic frame. It's hollow in the middle, and the wire is wrapped around thousands of times, I think 3,000 times around this loop. Notice that there's no battery in this setup. There is some wires connecting the loops to the ammeter, and that's it. That's the only thing in this circuit. Let me sort of balance that up so you can read that a little bit better. There's some glare on the screen. That's not too bad. And notice that sitting in my coil of wire, I've got a magnet. And notice that nothing is happening. There's no electrical current flowing through the system. But if I take that magnet and move it, even a tiny bit, back and forth, you can see the needle on the ammeter move. Not only that, but what if I move it one direction, push it into the loop, the needle moves one way, and if I pull it out of the loop, the needle moves the other way, in, out, in, out. I can actually generate an alternating electrical current by just taking this magnet and moving it back and forth in my wire. Again, the other thing to notice is if you look at the end of the magnet, this is a north pole of the magnet. If I push the north pole of the magnet into the loop, okay, in, out, in. So notice when I push it in, it deflects, well, which way does it go? If I push it in, it deflects that way. When I pull it out, it deflects the other way. Okay. If I flip it over and put the south side in, when I push the south side in, it deflects that way. If I pull the south side out, it goes the other way. So changing the magnetic field through this loop creates an electrical current. A stationary magnetic field does nothing, okay? But a changing magnetic field generates an electrical current. By the way, this is where electrical current comes from. When you plug something into the wall, you ask what's making that electricity. Somewhere there's a power plant that's moving a magnet in a coil of wire or spinning a magnet around in a coil of wire. If we took a magnet and we rotated it around in this coil, we'd get the same effect. And the energy that's used to move that magnet in that coil of wire comes from burning coal or oil, or it comes from a nuclear power plant, or it comes from water from a waterfall, from a dam flowing over a turbine and spinning that magnet around inside that coil of wire. And if I take that magnet and I spin it around inside that coil of wire, I generate a current that goes back and forth and back and forth and back and forth. And that's where the alternating current that comes out of the walls and the plugs in your house comes from. So the lesson here is that a static magnetic field won't cause stationary charges to move. It'll affect moving charges and cause them to deflect, and we saw that with the Lorentz formula, F equals QV cross B. But a changing magnetic field will actually cause static charges, for example, charges in a wire, to start moving. And that phenomenon of changing magnetic fields causing electrical currents is called magnetic induction.